Thanks everyone for attending. We are here today to talk about BIM and VDC and transforming the construction industry. I am Scott Anderson with TPM as a technical solutions manager. A little bit of background about me. I come from industry. I worked for general contractors of a wide variety of sizes and have been on projects specializing in BIM and VDC practices, and kind of a specialist in all things construction technology. Big advocate of using technology to help build better. So we'd like to discuss here today just anything BIM and VDC related. And so we want this to be a very interactive session. So thanks again for everyone for joining. Today we're going to discuss kind of construction modeling, model coordination with clash detection, scanning to BIM, as well as kind of some additional use cases that we're seeing more and more in the construction industry. We'll jump right into it. So really, when we're looking at BIM and VDC, BIM is really building information modeling. It's kind of the noun, as I would refer to it as, and the VDC is really kind of the verb. And VDC is virtual design and construction, and they vary there a little bit, as BIM is really just a digital representation of a building or structure. This is just any 3D model that has functional characteristics that we can leverage for further analysis of that construction project, or just utilizing drafting. There's quite a few authoring softwares that will produce a BIM. However, VDC is really that process, and that's really where we take a lot of those models and bring them together to do further investigation. There's quite a few other technologies and processes that come into play when you are doing a true VDC process. You'll end up leveraging things like laser scanning, prefabrication, 4 and 5D modeling, which I'll hit on here in a second, and traditional approaches would kind of deviate with the VDC process. And a lot of the process involves kind of creating digital representation of that building. It's an integrated approach that has a collaborative workflow to help optimize kind of project outcomes. It's really revolutionized the construction industry, in my opinion. It's allowed better communication, coordination, collaboration among those that need to have a stake in that design and in that construction. It's not just about creating those 3D models. It's really about changing the way we think about the design and the construction process. The traditional approach of design, bid, build can be kind of replaced with a more collaborative process, and it's kind of focused on, you want to focus this effort kind of with beginning with the end in mind. You'll hear stated a lot. And that's really where we want to identify use cases for these models throughout the process, and make sure we can leverage that throughout all phases of construction for added value on a project to help us really build better. It ends up creating a high quality building. It just allows for a lot better communication. So I mentioned there 4 and 5D BIM. So I do want to take a quick second to hit on the dimensions of BIM you'll oftentimes hear about. When you have the dimensions of BIM, you'll hear like 4D, 5D, 6D, and even XD. Those are really just different dimensions of BIM, such as cost and time. So you can add additional information into these typical models that you are using for drafting, and really help bring a lot of that extra information to a format that can be used and analyzed and visualized for all project stakeholders. So we can add costs into there and into schedules to do some simulations. There's quite a few different use cases there as well. When you're doing the VDC process, it's really important that you have, on construction projects in particular, that your team is all under the same understanding. We don't want to have, design teams that aren't comfortable sharing models. We don't want to have, contractors leveraging models for things that they shouldn't be. So it really becomes quite an effort to make sure everyone's aligned and on the same page. And There is a process called, creating a BIM execution plan or a VDC execution plan, depending on who you talk to, and also making sure that you align with any contract requirements. So oftentimes on this, as I mentioned, kind of beginning with the end in mind, the leveraging VDC on a project is oftentimes really driven by the owner, and that's really where the best source of pushing that effort really comes from, as that allows for everyone else to get on the same page to make sure we're providing the owner with the product that they're expecting, and it keeps everything pretty simple from kind of a contract requirement standpoint there as well. It's also really important to start to discuss in that BIM execution plan kind of LOD, which is a level of development. You'll hear mentioned a lot there as well. LOD is just you'll hear 100, 200, 300, 350, and 400 for levels of development. Those are really just defining on what systems are shown and how detailed those models are going to be. It helps make sure everyone's under the same impression of what will be provided with those models. So that way we know what we can use them for. That way we know we can use them for clash detection or for quantification, just all those use cases that I'll get into here a little bit more as well. So it's really important that you have a lot of those things up front if you're really going to be looking at doing the VDC process and leveraging these BIMs. So, benefits to the VDC process in comparison to traditional construction methods that, use 2D drawings and paper-based documentation. Leveraging those models and the process here really helps improve communication and collaboration, gives you a greater accuracy and efficiency, enhanced visualization, and increased sustainability. When you have, improved communication and collaboration, it enables all stakeholders to work from a single source of truth and a shared model. This helps really reduce, any miscommunications or conflicting information, and really helps, visualize what you're looking to do, what you're looking to build, what you're looking to design there. The ability to show that information in a 3D format just goes a long ways. You'll hear me kind of say, a picture's worth 1,000 words. I think a model's worth 1,000,000. It really helps explain what's going on and get everyone on the same page, and really speed up solutions and really increase that collaboration. When you have greater, accuracy and efficiency, they can be used to identify, those models can be used to identify conflicts early. That way we can, reduce those change orders and reduce any rework by planning ahead and seeing those issues earlier. When we have enhanced visualization and analysis, those models can be, used to create detailed visuals and simulations, helping, project stakeholders understand different design options and different scenarios that might happen on a project. Really helps increase the quality of construction and design. When you have increased sustainability, you're able to, look at those models to help analyze the environmental impact and allowing, for more sustainable design choices. You can do everything here from kind of solar analysis to looking at your actual kind of lead requirements based on model quantities and quite a few things there as well. So it really allows for, quite a few benefits, and a lot of it really comes down to just communication and documentation there. So it really allows everyone to see the same thing and make sure everyone's on the same page there. When we look at VDC for construction, it's really important to point out that VDC is that process, and it really goes through the project life cycle as a whole. VDC in construction, it really begins at the pre-con stages and ends all the way at operations and maintenance. It can be applied in various projects, various types, various contract structures, and really can help provide different use cases there as well, depending on the project for what you're going to want to leverage on these, leverage these models for. And one of the challenges that construction projects face is they do involve many different stakeholders, each with their own, goals and objectives. And this alignment of the stakeholders helps provide a shared vision for that project. And so it really can reduce conflicts and misunderstandings and lead to a more collaborative and successful project. Again, it's really important to make sure you have your VDC and VDC execution plans and any contract arrangements set up appropriately. So that way you can leverage these as a team. In the construction industry, we're looking at improving project planning, the design, the execution, and the management, and using these 3D modeling models for tasks such as scheduling, cost estimation, and clash detection. There's even more use cases that come along the way, but construction projects and teams are looking at leveraging these models that the design folks are producing for their own documentation all the time. And when I was on the contractor side, that was something, I would take any model I could, just, the visuals you would get from it, the enhanced, understanding from looking at that model really provided a value that was really hard to really even quantify. It just really helps speed a lot of things up there. In addition to kind of, reducing, looking at for tasks for the 3D modeling, scheduling, and estimation, and clash detection, all those things really help reduce project duration, cost, improve the quality and safety, and enhance kind of collaboration again among those stakeholders. So it's really something a lot of construction projects and teams are looking at leveraging more and more. We have all of these models with really good information, so it's important that we try to leverage them to just build the best we can. There's quite a few projects, and it's becoming pretty commonplace that construction teams are using these models, and it will continue to be used more and more throughout the industry. And those use cases will continue to grow, and the advances in technologies have been very impressive over the past few years, and I expect that to continue. And I'm looking forward to seeing what happens with some of the AI and machine learning, as well as a lot of the information we gather in other ways on site to feed into this VDC process. Where most contractors start on the VDC and leveraging those BIMs is really looking at the model coordination and kind of clash detection piece of the VDC process. Now, the VDC process, it's throughout that whole life cycle, like I mentioned, but when it comes to kind of the planning stage of construction, making sure that we are able to build that building in reality is really important. So you'll hear me say often, we're building this building digitally first. And what the VDC, model coordination process is really we take all of those models from the design teams and we aggregate them. We incorporate trade partner information and models as well into that. And we run clash analysis. This is done often through Navisworks or the ACC platform. This can be done at the early stages of a project, so you can identify any major design issues. I would consider that kind of the design coordination, where it would be pretty high level, looking at your large clashes, making sure you're not having any major structural issues. And then as your project kind of progresses further into that design and drawing development, that these models would end up becoming more and more realistic. And like the image on the right there, with hangers and a lot of that sub trade partner information. So that allows the project team to really build that building digitally first. And that clash detection process, it's a pretty tedious process, but it allows you to identify and produce RFIs that you might not see for months until you're standing underneath in the field. So we can't coordinate what we don't have or what we couldn't build based on the drawings and other information we have. So it's important that we have complete information so we can build that building digitally. And then once we do, we're able to run that clash analysis and produce quite a few different reports. And you'll see some kind of green and red photos over here showing and highlighting clashes where we have, a piece of pipe running into a steel member or a piece of pipe running into some duct elbows. And that identifies where we need to adjust our systems accordingly. So once all those models are aligned and that process of identifying all those issues is done, those corresponding trade partners and design teams go back and update their models to resolve those clashes, and anything that they can't or anything that needs further clarification can be submitted to the design team for an RFI or further clarification. This really allows us to, like I said, build that building digitally first. It's important to resolve all these issues before construction begins. This can help save time and money by avoiding any rework. It can reduce change orders and just, again, really increase the quality of the building for all of those project stakeholders. Once this coordination process has gone through some cycles and models have been updated and all of the clashes and interferences have been corrected, those drawings can then be utilized to produce prefabrication drawings or installation drawings or coordination drawings, depending kind of on your specification there admittedly as well. And that'll help make sure everyone is installing and building as planned here digitally, and holding everyone kind of accountable. Now, in order to run those clash detection and be a part of this BIM or be a part of this VDC process and produce a BIM, we have VDC Modeling Services that we also offer here at TPM as well. These modeling services can help fill any gaps that you all have internally, whether you have a large project that came up, or if you are on the contractor side, maybe you have a trade partner that is unable to participate efficiently in those coordination efforts. There is the ability to take that 2D shop drawing or detailed plans and turn that into reality and into a 3D model and build that building digitally first. These models can be used for design, they can be used for construction, and then at the very end as well, they can also be used for operational purposes. One of the benefits of the BIM modeling services, it just really, again, it enables better communication, allows a faster production of information and resolutions of issues. We can really keep all stakeholders up to date and help reduce any misunderstandings, again, from that visualization and extra effort that goes into that modeling, and making sure we have the latest and greatest information there as well. These modeling services can kind of range. Again, I hit on the different dimensions of BIM. We can have 3D, 4D, 5D modeling. If that is important to you, there's modeling services for creating different systems and different types that we can do to really help everyone become a player in the VDC process. And in addition to taking those models and leveraging them throughout, or creating those models, we also can, take our laser scanning information and produce models out of that as well. So I'm not sure how many of you on the line here are familiar with laser scanning and that effort, but that is we are a Leica shop here at TPM, and we can help facilitate any laser scanning efforts there as well as the scan to BIM effort. And what really happens here is that a laser scanner sits on a tripod essentially, and you place that in different areas of a room, and it shoots out lasers that capture points in measurements to create what is called in the industry as a point cloud. And you kind of see here on the photo on the left, there's all these little dots that end up creating that space. And you often hear laser scanning referred to as reality capture. And based off of all of that point cloud information, all that those measurements and that data that you captured, you're able to produce models out of that. So essentially, you see here the point cloud and this modeled pipe kind of overlaid on each other. That really, we're allowed, or we're able to essentially trace that point cloud to identify exactly where that pipe is in the real world. So this allows for increased as-built accuracy, and this can be done at the beginning of a project if your as-built are missing and you're working on a renovation space. This also can be done at the end of a project if you're looking to capture all the work that has been done and produce models there as well. There's quite a few things that we can do once we have that laser scanning data as well. There's deviation analysis that can be done based on walls and walls moving. There's the ability to produce that scan data into that model to create kind of a facilities maintenance model. You can do that even if the project really wasn't done in BIM technically. So that way, you can go back in and scan that project, get everything modeled, and produce that facilities maintenance model for your team. It allows for floor flatness analysis and really captures kind of anything historic or any like I said, that as-built information helps have a faster project delivery. You have improved accuracy for your models. It reduces the cost and rework of modeling, as you have a lot more measurements with that laser scanner than you could capture quickly and efficiently in the field with a tape measure. And it also allows for better project visualization for what is going on and helping explain and understand the story of that laser scanner. Whether that floor is off due to seismic issues or needs some floor flatness from a demo, you can help really tell a lot of those stories, and it just helps improve that project coordination so we can capture the real world conditions and bring that in so we can coordinate around that and or leverage those models for a variety of BIM use cases. Looking at additional kind of BIM use cases and related technologies. So again, I hit on the life cycle of VDC that you'll hear mentioning. We're designing a project, we're planning it, we're building it, and then we're handing it over to the owner. And throughout each one of those general stages, there is a large amount of opportunity to leverage these models in that whole VDC process. There is, at the design side of things, you can do some early engagement with that 4D and 5D modeling to help look at, planning that project and how the, project site will be mobilized. You can also look at assigning costs to that information there as well. So that way, when you're working on your design, you can make sure you're staying within budget, and also leveraging those models produced by design teams for the construction team to help monitor, any change orders or any, design changes that would happen from those designs being worked through. When you're working on the kind of the planning stage, we can start talking prefabrication. We can start taking all those models and all that coordination that we've done and memorializing that and producing prefabricated parts and elements. We can also leverage augmented reality. I should also mention virtual reality there as well with a lot of these models. And really, once we have these models on the project, there's just a lot of different things you can do there. And with that augmented reality and that virtual reality, the augmented reality, there's use cases there where you can do virtual mock-ups, and you can superimpose building systems into a building space and virtually see those building elements as you physically walk around that area. It's really powerful on construction projects where you can bring in your MEP models and see where those are going to be routed. There's also the ability to do some VR stuff there as well that will allow project teams to present different design criteria to maybe any project stakeholders and really help visually tell that story or sell that change potentially. As mentioned earlier, you have the ability to do quantification out of those models. That can be done, and in almost every stage here, essentially. You can do that at the beginning of a project and all the way at the very end, especially if you're handed over that model to the stakeholders and then the project owner. They can even look at, drafting their own drawings or looking at how that would, any quantities that would come from an addition maybe on their project and pulling any of that information out of there as well. And as mentioned, kind of facilities maintenance model, that's really, when you begin with the end in mind, as I mentioned, that facilities maintenance model is really where a lot of that value lies on this whole process. That's, that building is going to be used and maintained for 50 years. So there's a lot of yearly time savings and a lot of yearly value that can be produced from a facilities maintenance model. This can be from a ticketing systems to attaching O&M type information to model elements. So that way a facilities maintenance team can be on one side of the country, jump into that 3D model, take accurate measurements, get accurate information on equipment pieces, and even have some ticketing items of a building across the country. And it really allows for a high value deliverable for the owner and making sure that they enjoy their building for the next 50 years. And also I want to bring up virtual mockups. This is really big kind of in that design and planning phase. The virtual mockups allow for a deeper investigation that you might not necessarily cover in your clash detection process. And you can really, do virtual mockups for really about anything technically, but, looking at using virtual mockups to help explain and discuss a curtain wall system and some of those type of details. It can really help explain what might be going on that a 2D document just wouldn't show. And you can also do that virtually without having to go to the job site, see it in person, have someone mock it up, and that turnaround time can be a lot quicker to help make informed decisions faster. So yeah, VDC in construction, it's starting to get leveraged more and more by project teams. It's getting dictated more and more by project stakeholders, and then with the almost standardization of Revit within the design industry, there's been more and more usage of those models for a wide variety of use cases, and that is continuing to grow. So here at TPM, we're looking to help you all in any of those ventures. We can help facilitate VDC coordination, laser scanning to BIM. I also did want to mention too, I forgot here as I say that scan to BIM aloud, there's also the ability to do kind of scan to mesh. It's a little bit of a cheaper alternative, and it's less accurate, but it takes that point cloud data and turns that into kind of a solid mesh object. It's a lot lighter than model elements from Revit that have been traced over that point cloud. Essentially, it takes that point cloud information as is and creates that mesh off of those points, and that can be also pulled into models to be viewed. It can be brought in for clash detection, so it can be some really quick analysis on anything that needs to be done there as well. But those use cases are continuing to grow, and you're going to see more and more emerging technologies leveraging AR and VR, photogrammetry, and other similar technologies. And a little bit about TPM. So TPM is a Autodesk Elite partner. We also have a few other softwares that we support and sell. We can really help out in any way, shape, or form that you all need for the software and services standpoint. We have multiple locations, 95 plus employees. We've been around for 50 years. You can kind of see our reaches in the southeastern area, but we are willing and able to cover a larger area than that. We have quite a few different suites of software and customers that we work with regularly. So if anyone needs to reach out for any of that type of software or services, we're here to help. Okay. Well, thank you everyone for joining the webinar. Look forward to chatting with more of you about VDC and construction related activities.